Hey everyone, Math 103, we're working on section 5.4 today on special factoring. I'd like everybody to pause the video and start with a warm-up. We're going to FOIL and simplify those four. So FOILing x squared minus 2x plus 2x minus 4. Two middle terms cancel and we get x squared minus 4. Next one, x squared minus 3x plus 3x minus 9. Again, the middle two terms cancel, and we get x squared minus 9. Next one, 4x squared minus 6x plus 6x minus 9. So we get 4x squared minus 9. And the last one, 9x squared minus 12x plus 12x minus 16. Middle two terms cancel. We get 9x squared minus 16. So the pattern is, every time those middle two terms are going to cancel each other out, and what we're left with is just the first term and the last term, which just so happen to be the square of the first term minus the square of the last term. And this is the famous formula called difference of squares. And we're going to be using this in factoring. So what we're going to do is start with an expression that looks like this and turn it into an expression that looks like this, going from things that are added or subtracted together to things that are multiplied. So one of the main steps in being able to factor difference of squares is to pick out the value of a and b. So take a look at these first four, compare it with this formula, and pick out the values of a and b. So in the first one, notice we have a plus b times a minus b, and here we have x plus 2 times x minus 2. So that would make a x and b 2. In the second one, we got x plus 3x minus 3. That's going to make a x and b 3. Notice that it's not negative 3 because the negative is already in the formula and the plus is already in the formula. So we can ignore those signs. We can ignore this sign. We're just going to pick out the positive values. 3. The first term is 2x, so a is going to be 2x. The second term is 3, so b will be 3. And for number 4, first term is 3x, so a is 3x, and b is the second term, which is 4. Now, one thing we're going to need to be able to do is to recognize when a number is a perfect square. So on the top of page 2, take a look at that list of numbers and circle all of the perfect squares. So out of this list, the perfect squares are, and this is one that a lot of people miss, is 1. 1 is actually a perfect square because 1 times 1 is 1. We have 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Those numbers should jump out at you as being perfect squares. And if you can recognize these numbers, it'll be very helpful in determining whether or not an expression is difference of squares, and then they'll tell us how to factor. So factoring difference of squares, first thing we need to do is be able to tell whether or not the terms are indeed perfect squares. They have to be perfect squares. They have to be something squared in both of these positions. So let's take a look at this example as we go through these steps. First example is x squared minus 16. Well, 16 is in our list. 16 is a perfect square. And any variable to an even exponent is a perfect square. If it's to an odd exponent, it is not a perfect square. But this one is even, so this x squared is a perfect square. All right, now we're going to find a and b by taking the square root of both of these terms. We're going to take the square root of x squared and the square root of 16. A is the square root of x squared. Now if you take the square root of something squared, you just get the variable itself, x. And the reason that's true is we're going to take that exponent, if we take the square root, we divide it by 2. So if this were x to the 6th power, the square root would be x to the 3rd. B is the square root of 16, and that is 4. Alright, so now we have our values of a and b. Now we're going to plug a and b into the difference of squares formula. Alright, we're starting with the squared form over here, and we're going to this factored form. So we want a plus b times a minus b. So that is x plus 4 times x minus 4. And there's the factored form of x squared minus 16. Your turn number 1. There's 2 of them. So we're going to confirm that these are perfect squares. We have a even exponent on the x, so that's a perfect square. 36 is in our list, so that's a perfect square. So we'll take the square root of the first term, x squared, to find a. Divide that exponent by 2. 2 divided by 2 is 1, so we get x to the first power. And for b, square root of 36 is 6. Now we can plug these into the difference of squares formula. So that gives us x plus 6 and x minus 6. Part B. Now these are in reverse order, but that's okay, it works exactly the same. Perfect square, perfect square. So to find a, we'll take the square root of 4, and that is 2. To find b, we got the square root of x squared. Ignore the negative, just do b squared. Square root of x squared is x. So that goes into the perfect difference of squares formula. So we got 2 plus x and 2 minus x. Now some terms will have a mix of numbers and variables. So just take the square root of each part separately. So we do have perfect squares here. A is going to be the square root of this entire first term, 9x squared. So we'll take the square root of 9 and get 3. Take the square root of x squared and get x. So A is 3x. B is the square root of 49, and that is 7. So into the difference of squares formula, we got 3x plus 7 and 3x minus 7. Your turn number 2. So we do have perfect squares here. We're going to take the square root of 25x squared to get a, and that is 5x. And for b, square root of 1 is 1. So into the difference of squares formula, we got 5x plus 1 and 5x minus 1. Part B, 16 minus 9x squared. Taking the square root of the first term, 16, we got 4 for A, and the square root of 9x squared gives us 3x, and that is B. Plugging this into the formula, we got 4 plus 3x, and 4 minus 3x. Now, in the next example, we have some higher powers. Keep in mind, we're always just going to divide that exponent by 2 when you take the square root. So x to the fourth, y to the fourth, minus 64. This is a perfect square because all of the exponents are even. Now, when taking the square root of something with multiple variables, we'll just do each variable separately. So it's the square root of x to the fourth, divide that exponent by 2, and you get x squared. Same deal for y to the fourth, that turns into y squared. Then b, square root of 64, which is 8. So plugging into the formula, we got x squared, y squared, plus 8, times x squared, y squared, minus 8. Your turn number 3. So these are all perfect squares. We've got even exponents here, and 64 is a perfect square. So taking the square root of the first term, x to the 6th, y to the 4th, we're going to divide both of these exponents by 2. Turns that into x to the 3rd, y squared. And for b, square root of 64 is 8. Plugging into the formula, we've got x to the 3rd, y squared, plus 8. X to the 3rd, y squared, minus 8. Now I've got 81 minus x squared, y squared. So these are all perfect squares. Square root of 81 is 9. And the square root of x squared, y squared is xy. Plugging into the formula, we got 9 plus xy and 9 minus xy. Now there may be variable parts in both terms. It'll work exactly the same. So we are going to factor 100 x to the 4th minus 64 y to the 6th. So we have all perfect squares. For a, we're going to take the square root of the first term, 100 x to the 4th power. So the square root of 100 is 10. Square root of x to the 4th is x squared. For b, we'll take the square root of the second term, 64y to the 6th power. Square root of 64 is 8. Square root of y to the 6th is y to the 3rd. I'll plug these into the formula. We get 10x squared plus 8y to the 3rd times 10x squared minus 8y to the 3rd. Your turn number 4. So taking the square root of the first term, 4x squared, we get 2x for A. And taking the square root of 9y squared, we get 3y for B. Plug A and B into the formula, we get 2x plus 3y times 2x minus 3y. Part B. (25x to the 8th minus 16y to the 10th). Okay, all the exponents are even, so those are perfect squares. 16 and 25 are both perfect squares. Taking the square root of the first term, 25x to the 8th. Square root of 25 is 5. Square root of x to the 8th is x to the 4th. And for B, square root of 16y to the 10th. Square root of 16 is 4. Square root of y to the 10th is y to the 5th power. Plugging A and B into the formula, we get 5x to the 4th plus 4y to the 5th times 5x to the 4th minus 4y to the 5th. Now we're moving on to perfect square trinomials. Please FOIL and simplify those two expressions. So here's those two expressions, foiled and simplified. Now last time when we did this, we had opposite signs here. So that means our two middle terms had opposite signs and they canceled each other. But here we have the same signs, so we get two middle terms with the same signs. So when we combine them, that has the effect of doubling one of those terms. And that leads us to the perfect square trinomial formulas. So when we take those two middle terms and combine them, we double the coefficient to 4. So here in the formula, that's why we're multiplying by 2, because we have two of these a times b terms. So with this one, a is x and b is 2, so we got 2x. We doubled it to negative 4x. All right, so double a times b. So when we're factoring perfect square trinomials, the procedures can be very similar to factoring difference of squares. We're first going to look at the first and last terms to see if they are perfect squares. Then we'll find a and b by taking the square root of both of those perfect squares. Next, we're going to test the middle term to see if it really does equal 2ab. We're going to find the value of a and b, multiply them together, and multiply by 2 to see if it matches that middle term. And then finally, we'll plug it into the formula, and then FOIL to check. So our first example is 9x squared minus 24x plus 16. Now the middle term, that doesn't have to be a perfect square. We're only checking the first term and the last term. And those are all perfect squares. So we can find a, square root of 9x squared. So that's 3x, b, square root of 16, and that is 4. Now let's check that middle term. So we'll find 2 times a times b, which is 2 times 3x times 4. 3 times 4 is 12, times 2 is 24, and we have an x. That matches the middle term, confirming that this is a perfect square trinomial. So that means we can use the formula now. Now let's look at the middle term. The middle term tells us which version we're going to use. We have a negative middle term, so we're going to use the negative version, a minus b. So our factored form then is a, 3x, minus b, which is 4, and then we square it. 3x minus 4 squared. Your turn, number 5. All right, we got 4x squared, that's a perfect square. Take the square root and get 2x. 1, that's a perfect square. Take the square root and get 1. All right, now we found ab, so let's find the value of 2 times a times b. So that's 2 times 2x times 1, and that is 4x. And that matches the middle term. So we have a perfect square trinomial. We have a positive version, since the middle term is positive. So that's going to be 2x plus 1 squared. B. All right, we have perfect squares here, perfect squares here. We're going to take the square root of 16x squared, get 4x for a, take the square root of 25 and get 5 for b. Now let's check the middle term, 2ab, which equals 2 times 4x times 5. 4 times 5 is 20, times 2 is 40. And keep the x. 40x matches the middle term. So we have a perfect square trinomial. Now we've got a negative version, so that means we're going to use the negative version over here. So that will be 4x minus 5 squared. C. All right, we have perfect squares here, perfect squares here. So we'll take the square root of 36x squared and get 6x for a. Take the square root of 25 and get 5 for b. 2ab now is 2 times 6x times 5. 6 times 5 is 30, times 2 is 60. And keep the x. So 60x, that matches the middle term, so we have a perfect square trinomial. We have a positive version of it. So our factored form will be 6x plus 5 squared. D. So A will be the square root of 25x squared, and that is 5x. And B is going to be the square root of 49, which is 7. 2AB is 2 times 5x times 7. 5 times 7 is 35, times 2 is 70, x. That matches the middle term. We got the negative version, so we're going to plug A and B into that version. We got 5x minus 7 squared. Now, some perfect square trinomials have more than one variable, but the process is exactly the same. So A will be the square root of the first term. Square root of 64x squared is 8x. And B, the square root of 9y squared, which is 3y. Now let's check the middle term. 2ab is 2 times 8x times 3y. 8 times 3 is 24, times 2 is 48. And we have an x and a y. And that matches the middle term. So this is a perfect square trinomial. We have the positive version. So that'll be 8x plus 3y squared. And that brings us to your term number 6. So to find A, we'll take the square root of the first term, 4x squared, get 2x there. And for B, we'll take the square root of 9y squared, you get 3y. Checking the middle term, 2ab, that's 2 times 2x times 3y. It gives us 12xy, which matches the middle term. We got a positive version here, so that's going to be 2x plus 3y squared. B. So to find A, we'll take the square root of the first term, 9x squared, and get 3x. To find B, we'll take the square root of the last term, 49y squared, and get 7y. Checking the middle term, 2ab equals 2 times 3x times 7y. 3 times 7 is 21, times 2 is 42. So that's 42xy. And that matches the middle term. Now we've got a negative version, so we use the negative version of the formula. So 3x minus 7y squared. C. But this one looks a little bit different because we got some higher order powers. This is going to work exactly the same way. Take the square root of the first term, 16x to the fourth. Square root of 16 is 4. Square root of x to the 4th is x squared. So we get 4x squared for A. For B, square root of 25y squared. That gives us 5y for B. Now let's check the middle term. 2ab equals 2 times 4x squared times 5y. 4 times 5 is 20, times 2 is 40. Keeping the x squared and the y. So 40x squared y matches that middle term. And we've got a positive version here, so we use the positive version of the formula. 4x squared plus 5y squared. D. So D looks kind of crazy. Got a bunch of higher powers here. It looks like it might not even be factorable. But if you recognize your perfect squares, then you'll recognize this as being a potential perfect square trinomial. To find A, we'll take the square root of the first term, 121x to the 6th. Square root of 121 is 11. Square root of x to the 6th. Divide that exponent by 2 to get x to the 3rd power. So A is 11x to the 3rd. B, square root of 144 y to the 4th. Square root of 144 is 12. Square root of y to the 4th is y squared. And now let's check the middle term. 2ab equals 2 times 11x to the 3rd times 12y squared. All right, 11 times 12 is 132, times 2 is 264. And then we'll keep our variables, x to the 3rd, y squared, and we have a match. So this is indeed a perfect square trinomial. We have a positive version, so we're going to take A, 11x to the 3rd, plus B, 12y squared, square the whole thing, and there's the factored form. All right, so difference of squares and perfect square trinomials are some of the most important factoring forms we're going to see. We'll see them throughout the remainder of this chapter and the next chapter. Have a great day, everyone.